Okay, good day class. Alright, so last lesson we have learned until ellipse. Alright, the standard form of the ellipse and the general form of the ellipse. Okay, and we have solved some STPM partial question related to ellipse. Alright, so today we will see another definition for ellipse. Alright, so before this, we do the definition for ellipse. Follow this. Okay, we definite the ellipse by using this definition. It is the sum of each distance from two fixed points are constant. These two focus are the fixed points, so the sum of the distance of the moving point from these two fixed points are the same. Means PF1 plus PF2 equals 2A. Alright, before this we are using this definition to find the standard form, the equation of the standard form of the equation of ellipse. Alright, so today we will see another definition for ellipse, and actually this definition also used for others conics. Alright, okay, so we call this an ellipse with the definition of eccentricity. So we are using the definition of eccentricity. Okay, so let's see what is the definition of eccentricity. Okay, so number one, a conic is defined as the locus of a point which moves so that the ratio of its distance from a fixed point to its perpendicular distance from a fixed line is a constant. You see, this definition is used for all conics. Means included ellipse, parabola, and also hyperbola. Also can use this definition. So again, I repeat. So this definition is talking about the ratio. The ratio of a moving point, the ratio of the distance of a moving point from a fixed point and its perpendicular distance from a fixed line. Okay, and this ratio should be a constant. Alright, so let's look at this diagram. This one explains. So this is the ellipse. Alright, let's say this is the ellipse. Okay, this is the fixed point, F. And this is the line, a fixed line, and we call it directrix. It's a vertical line. Alright, so you have a fixed point, you have a fixed vertical line. So the moving point P will move such that, such that the ratio of its distance from the fixed point to the distance of this moving point to perpendicular distance from this moving point to a fixed line. Alright, and we call this fixed line directrix. Okay, so this is the definition. So PF over PN, because ratio PF over PN, the distance from P to F, okay, over the perpendicular distance from P to a fixed line, Pn, should be equals to a constant. And we name this constant E. Alright, later only we discuss other. So we just talk about the definition of eccentricity. Alright, so PF over PN is equals to the constant E. Alright, so look back here. So number two, the fixed point is called focus okay, and the fixed line is called directrix. Alright, so the constant ratio is known as eccentricity. That's why we use the E to represent it. Alright, this constant ratio, we call it eccentricity of the conic, and is denoted by E. Alright, of course this E is not the natural number in your calculator. Alright, this E represent the eccentricity. Okay, so let's look at the value of the E, how it can determine the shape of the conic. So you see, if the value for this E lies between 0 to 1, then the conic become ellipse. Alright, so means for an ellipse, PF over PN should be a value lies between 0 to 1 only. Okay, when E equals to 1, means this distance and this distance the same, then the conic become parabola. You see, the next conic that we are going to discuss will be parabola. And when E is bigger than 1, when this ratio is bigger than 1, then the conics become hyperbola. Alright, So you see, this is the definition of eccentricity for all the three conics. All right, so when we go to parabola and hyperbola, yes, we are using this definition. Okay, we are using this definition. So for ellipse, we have two definitions. One is this eccentricity, one is before this, which involve two fixed points. Remember? Okay. All right, so now we emphasize on ellipse. Okay, so this is the standard form of ellipse. Still remember, with center HK. All right. So by using this definition of eccentricity, so PF over PN will be equals to E, and actually PF is C, and PN is A. This is the definition. You will get something like this. All right, so C is the distance from P to the focus, and A is the distance from P to the directrix, this vertical line. So directrix can be horizontal line. It depends on the shape. Remember, it depends on the shape of the hyperbola, whether it's horizontal or vertical. If it is vertical, then the directrix will be a horizontal line. All right, so this is the axis of symmetry. Okay, and what is C? As we have discussed, C square is A square minus B square, because this is horizontal, right? So horizontal, A square is bigger, so A square minus B square. Okay, and you look at the focus. The coordinate for the focus should be AE 0. All right, and the equation for the directrix is x equals A over E. Okay, so the equation of the directrix is x equals plus minus A over E lah. It depends lah, It depends on your A lah. Okay, so look at the value of E. How it affected our shape of the ellipse. All right, so we know that just now we say, right, when the value for E is between 0 to 1, then the conic is an ellipse. All right, so when the E is closer to 1, because 0 to 1, so when E getting bigger and bigger means and close to 1, then you see the shape of the ellipse is actually like slim. Okay, slim. All right, where when E is approaching to 0 means the ratio is very small. So actually you see that the ellipse is more round. Okay, that's why it says show the roundness of the ellipse. Okay, and remember, actually ellipse is related to circle, right? It's a special case of circle. All right. Okay, so let's see. By using the definition of the ellipse, definition of this eccentricity lah. Definition of this eccentricity. So PF over PN equals to E. So we shift PN here. So use the formula for distance to calculate PF with all these coordinate and PN. Alright, so actually PN very simple because it is a perpendicular line. Alright, so we just talk about X only X minus X because Y minus Y 0 Okay, then when we squaring both sides, then and expand it, then it become like this. We expand line by line. Alright, then we factorize x squared. We write x squared and y squared here. Then all other constants shift to the right hand side. Okay, and we make right hand side as 1, right? So it means that we multiply this equation by a squared 1 minus e squared, then you get this thing. Alright, and we write it is in the standard form lah, b squared lah. So where your b squared is actually 1 minus e squared. Alright, it's actually 1 minus e squared lah. Okay. So you see, from the definition of eccentricity, we also can get the standard form of the ellipse. Alright, so remember the two definitions for ellipse, or one using two fixed points. So this one using one fixed point and one directrix. Okay, so let's see one example. That we have not many examples for this type, for this definition of eccentricity for ellipse. Alright. Okay, number 1, find the eccentricity and the directrix of this ellipse. Okay? Alright, so this is the solution. Alright? So actually you are given this in general form. You are given the equation of the ellipse in general form. Alright? So we rewrite it in standard form. So we know that standard form, right hand side must be 1, right? So I multiplied the whole equation by 1 over 5. Okay, so when multiplied with 1 over 5, this is 2 over 5. So multiply 2 over 5 means divide 5 over 2 lah. So this is 3 over 5. So 3 over 5, multiply 3 over 5, same as divide 5 over 3. Okay, this one become 1. Alright, so from here you get your A and B lah. Sorry, it's A square. Sorry, it's A square and B square. Alright, you get your A square and B square. Alright, then we calculate the C square lah. So C square is A square minus B square, so you get this. Alright, so C is 5 square root 5 because this is actually 25 times 5, right? So square root 25 is 5 lah. Alright, so this is your C. So the question wants us to calculate the eccentricity, right? So eccentricity, the formula is C over A. Alright, so this is C over A. A is 5 over 2. So over means all we shift to multiply become 2 over 5 lah. So after you simplify, yes, this is your eccentricity. Okay, square root 5 over 3. So if you use a calculator, actually you can, when you calculate it, actually you get that square root 5 over 3. So square root 5, square root 5 divided by 3 is actually 0.75. 0.75 is quite close, it's closer to 1, right? Alright? It's actually closer to 454. So means it's closer to 1. So if closer to 1 means it's quite slim. It's quite slim, this ellipse. Alright? So this is the eccentricity, and the question wants you to find the directrix. Alright? So the formula for the directrix is, because this is vertical, so it's x equals A, sorry, this is horizontal, okay, because A bigger, alright, A bigger, so this is horizontal, so the directrix will be vertical line, so if vertical line, so it's x equals A over E, so A is 5 over 3, E is from here, alright, and then we don't want square root, we don't want a third number at the denominator, right, so we rationalize it, okay, multiply sub 5 over sub 5, so you get, this is the directrix, alright, this is the equation of this vertical line. This vertical line, directrix. So it's x equals 3 square root 5 over 2. Alright, so this is the equation related to the definition of eccentricity. Okay? Alright, so next. Okay, so next part, we will go to tangent to an ellipse. Alright, we will go to tangent to an ellipse. Alright, how to, for circle, we have learned how to find the tangent to the circle. Alright, so we also will talk a little bit about how to get the tangent to an ellipse. So we know that tangent is a straight line, right? And the equation for a straight line is y equals mx plus c. Let's name it equation 1. Okay, and this is the general form of the ellipse. It's actually come from here. This is standard form. So when I multiply the whole equation by a square b square, alright, so when this term multiply a square b square, a square simplified, so left b square x square. So this one also the same. So 1 multiplied this one, you get this. Alright, it's a general form. So let's name it equation 2. So to find the point of intersection, right, tangent, the contact point. So we sub 1 into 2. Alright, so like this. Sub your y into here. Then we expand it. Alright. So after we expand it, okay, so you get this, expand and simplify in a quadratic form, x square, x and c, in a quadratic form. All right, because this line is a tangent, so definitely this quadratic equation will have equal roots, or only one root, right? Because only one intersection point, tangent is only touched at one point, right? Therefore, your b square minus 4ac is equal to 0. We use this determinant. Then, so your b square minus 4ac. Alright, so you can go back and try simplify it. Alright, so I don't show here. So after we expand and simplify, so at the end, after simplify, we get this conclusion. C square equals b square plus a square m square. Alright, so from here we can say that hence y equals mx, this straight line is a tangent to this ellipse if this happen. Okay, and the equation of the tangent will be y equals mx plus minus c. This is c. Alright, this is c. Okay, so this is a concept. This is a concept for excuse me. So this is a concept related to tangent to the ellipse. All right, okay, so we will see one past year question, those involve tangent to the ellipse, all right, which is in STPM 2012. Okay, other than that, in the textbook that you are using now, there's no exercise related to tangent to the ellipse. So you can refer to the Blangi textbook. All right, Blangi textbook, exercise 5.6, page 209. Okay, so I want you to try question 2 to question 5. All right, so Xiaofeng, all right, please snap the exercise 5.6 in page 209, question 2 to 5, and share it to the class group, the group of the WhatsApp group of the class, okay, so that your friends can do these 4 questions. All right, so these 4 questions are related to the tangent, okay, the old Blangi textbook. Okay, so let's look at this STPM 2012. Okay, so the question say a straight line 2x plus y equals 1 intersect an ellipse 4x squared plus y squared equals 5 at points A, B. All right, this one, so I know that this is a vertical ellipse. How I know? Because when you rewrite this in standard form, when you write this one in standard form, the whole equation divided by 5. So this is over 5 over 4. This is over 5. So definitely B bigger. So I know that this is a vertical ellipse. All right. So this is a ellipse and this is a straight line. And this straight line cut the ellipse at A and B. All right. So A, find the coordinates of points A and B. 4 marks. This one no problem. Just solve simultaneous equation. All right, so I rewrite the equation of the straight line into this form. So that's why I know the line is slant like this, because its gradient is -2. All right, so this is 1. The ellipse is 2, so sub 1 into 2. So sub your y inside here. All right, then we expand this. 4x squared minus 4x plus 1. Then we rearrange and get a quadratic. All right, simplify it. Because 8, 4, 4, so simplified by 4 and factorize it. Okay, so after factorize, so I found 2 values of x. Okay, x equals -½ or x equals 1. Okay, then sub these 2 values of x into equation 1. Into equation 1 easier. All right, then you will find when sub x equals -½ here, so your y is 2. When you sub x equals 1, then your y is -1. All right, so from the diagram, A come first, right? So I label this one as A. Okay, B is here. So the value for x definitely is bigger. So I write this one as B. So this one 4 marks. Find the intersection point. Okay, so the next one, B, this is 7 marks, this part. So they want you to find the tangent to the ellipse at point A and B, intersect at point C. Find the coordinates of point C. This one is 7 marks, so means that it's actually quite long. This question actually quite long. So what does this mean? It means that, okay, this is point A, right? Okay, so this is a tangent at point A. All right, this is point B. So this is a tangent for point P. Okay, extend A again. All right, you see that this tangent at A and tangent at P, they meet here. This is point C. So the question wants you to find this point. Okay, so we know that to find this point, we need the equation of these 2 tangents. We need the equation of these 2 tangents so that we can solve simultaneously to find C. Okay, so now the question is how to find the equation of the tangent. All right, so we know that you have learned in Form 4 differentiation. All right, the equation of a tangent is actually dy dx. Using this method will be easier. Okay, so okay, I will overlap here. Okay, so we are going, this is a curve, right? This is a curve. 4x squared plus y squared equals 5. This is a curve. So I'm going to differentiate this one. Okay, I'm going to differentiate this one to get dy dx. All right, and this is something that something new in differentiation. We call it differentiation of implicit function. Okay, so the normal differentiation is, okay, I show you lah something. Okay, let's say you have y equals 2x squared plus 4x minus 3. Let's say. So how you differentiate? So differentiate y means you get dy dx, right? Remember how to differentiate? I remember in chapter 1 we have discussed a little bit. So differentiate 2x squared. So index move in front. So 2 times 2, 4x. Index minus 1 is 1. Differentiate 4x, 4. Differentiate constant, 0. Remember differentiation? It's just that now something special. I'm like teaching you all before, if I'm not mistaken. I teach you before how to differentiate this implicit function. Okay, because this is old syllabus question. So that to do this one, you have done your differentiation. That's why they come up question like this lah. Okay. In now the new syllabus, no, I don't think they will come out something like this. Because you haven't learned this type yet. But doesn't matter. You learn something new, then maybe you can apply it in the exam. Alright? So this is how we differentiate. We call it implicit function. We call it implicit function. Means, you see, your y also got power. Not only y. The normal one you have learned in SPM, only y. So when you differentiate, become dy dx, right? So this one, y also have power. We call it implicit function. How to differentiate? Actually, very simple. Very simple. Listen carefully. Okay, differentiate 4x squared. As usual, index in front. So 2 times 4, 8. 8x. Index minus 1, right? So become 1. Alright? This is the implicit part. How to differentiate y squared? Very simple. We differentiate as usual. Index in front. In front is 1 ma. So 2 times 1, 2 lor. Copy your y. Index also minus 1. Also become 1 lor. Alright? Just add one term. dy dx. When come to SEM 2, semester 2, I will tell you why we need to write dy dx here. Okay? So meanwhile, you just memorize it. If terms in x, just differentiate as usual because we may differentiate y with respect to x ma. But when you differentiate terms in y, okay? Remember, you differentiate as usual. Use the technique, the same technique, just that multiplied with dy dx. Alright? So actually this is also same, right? You differentiate 1y, you get 1, right? Then dy dx. See that? Okay? So differentiate constant, you get 0. Yes, from here we rearrange it and we get dy dx. But now your dy dx is in terms of xy lah. SPM level, your dy dx in terms of x only. Okay? So 8x shift here, minus 8x. 2y shift here, over 2y. So after simplify, my dy dx is negative 4x over y. Alright, so remember you have learned this one in SPM. dy dx is actually same as gradient of tangent, right? Okay, so at point A here, at point A, where x equals negative half and y equals 2, coordinate. Okay, so the dy dx at A will be sub your x and y inside here. Alright, so I get that dy dx same as gradient of tangent is 1. Okay, so sub in here, y equals mx plus c because tangent is a straight line. And at point A, x is negative half, y is 2. So sub in, x negative half, y 2, and gradient is 1. So from here we get our c. Alright? Therefore, the equation of the tangent at point A is y equals x plus 5 over 2. I name it equation 3. So at point B, also we do the same. So the coordinate for point B is x1, y negative 1. So sub into the dy dx. Minus 4x over y. So you get that the gradient of tangent is 4. Okay, so sub your x and y into y equals mx plus c and the gradient 4. So you get that c equals negative 5. So at point B, the equation of tangent is y equals 4x minus 4. Alright, so I name it equation 4. So now I get both the equations of the tangent. I got already. So solve simultaneously lah. So I use 4 minus 3 lah. 4 minus 3. So y minus y, 0. 4x minus x, 3x. Negative 5 minus 5 over 2, 15 over 2. All right, so you get x equals 5 over 2. Okay, then sub into the either one, sub in either one. Oh, so I sub in 1 actually. Okay, I sub in equation 3. Oh, I sub it in equation 3. So x5, oh, sorry. Oh, sub into equation 3 here. So y equals x plus 5 over 2, so it's 5. So therefore, the coordinate for point C is this one. Alright, so 7 marks, this thing. So this one play a very important role. Okay, if you use solving simultaneous equation to calculate MC, then very long and complicated. Okay, alright. So next, C. Find the shortest distance from C to the line AB. Okay, so still remember the formula for shortest distance. So this is line AB. This is C. So find the shortest distance. Means shortest distance is what? Perpendicular distance. Perpendicular distance, remember? So means we need the equation of line AB lah. In general form. We have to find the equation of line AB. So very simple. Gradient of AB, because we have both AB already. We have both coordinate of AB. So find the gradient of AB equals -2. Alright. Then choose either one point. I use point B lah. Sub in point B and also gradient. So this is the equation of line AB. This is the equation of line AB in general form. So remember the shorter distance. That's why I have to rearrange it in general form. So 2x, C is this one, sub C, because shorter distance from C to AB. So 2x plus 5, y is 5 minus 1, modulus, square root, 2 square plus 1 square, 2 square, 1 square. Okay, so here is 9. So 9 over square root 5. So we don't want 5 in the denominator, right? So we rationalize it, multiply this one. Okay, so you get this. So this is the shorter distance. Alright, this one give you also 4 marks. Because you need to find the equation of AB. Then you need to use the formula for shorter distance. Okay, so this is so far the only question related to tangent to the ellipse in STPM question. Okay, it came out in 2012. So already 8 years they never asked. So I really hope that you can do some question in the old Belangi textbook. Okay, so that takes some experience to answer question like this. Alright, so today's lesson I will stop here. So you please do it as you please do this for your homework lah. Okay, so tomorrow I will send you another video. Okay, thank you class.